Welcome to the Philosophy of Science lecture. Last time I stopped at the beginning of part 4. I spoke about the difference and the gradual distinction between theoretical concepts and observation concepts. And in midst of them, somehow lying between them, there are the empirical disposition concepts. And we stopped at the problem, how can we really distinguish observation concepts from theoretical concepts in the face of all these criticisms in philosophy of science and in other intellectual disciplines or fields where people are saying more or less every concept is somehow theory laden, so it's not possible to make a separation here. But of course, for every theory of empirical science, it is essential to have some kind of separation or distinction here, because, I mean, after all, what distinguishes empirical science from speculation or ideology is that you can empirically test which of two rivalizing theories is better confirmed and which is less confirmed. So you need, for every such a test, you need some kind of an independent judge, and this independent judge is the empirical facts which you can observe or measure, and there should be agreement on these empirical facts between the proponents of the two rivalizing theories, but this is only possible if these empirical facts on which they agree are neutral and not dependent on their theoretical prejudgments, right? So therefore it is still a very important task to ask which criteria of separation can we have here. And I mean, so I already said that of course the separation criterion is gradual, so you have more or less observation concepts, or concepts which are more or less observable. So at the lowest end of the scale, the most observable concepts are common sense concepts like table red, greater than, these concepts here, right? And concepts like electric fields are no doubt totally theoretical, but how could you discriminate that? So this is our question, and Gerhard in his testability meaning paper suggested that an observation concept should just be defined as a concept, as a concept designating a property that can be observed by every person under normal conditions of observation. So it can be observed, he says, by one or several acts of pure perception. Okay, so of course this is our intuitive idea. Something is observable if it can be, and a belief expresses an observable fact. If the truth value of the believed can be ascertained by means of one or several acts of perception, right? That is the idea here, right? So, first of all, if you have this idea, it must become clear that the concept of observability is not a semantic concept. This was a misunderstanding which you even find in some writing of the earlier Gerhard, that there is a kind of semantic property of a concept which makes it observational. But that cannot be, because what is observable depends on the perceptual abilities of an organism. So observability is of course a concept which is relative to the organism, right? Humans cannot perceive magnetic fields, but certain snails can, or some kinds of birds or fish can perceive electric fields or magnetic fields. So this is point one. It's a psychological concept, or if you want, a biological concept. It's not a semantic concept. Yeah? This point is also made by Van Fraassen in his The Scientific Image. Right? Okay, but this was also clear for the late Gerhard, that observation is not a semantic concept, but as he says, Gerhard said, a pragmatic concept, but actually it's a psychological concept. So this is point one. Point two. This definition is not satisfying because you don't really know how to empirically ascertain, or what is the empirical criterion for a belief being the result of mere perception, right? So we want to arrive at the notion of a theory-neutral observation concept. But the opponent to this notion can say at this point, well, look at how our visual systems, the visual parts of our brain work, the vision centers in our brain. There is no separation between perception and interpretation, right? There is the two-dimensional image on the retina from which our brain constructs a three-dimensional, so to speak, object which can be regarded as an inference to the best explanation, right? So the three-dimensional image, this table which I have in my mind, is constructed from all these different two-dimensional patterns, vision patterns, which the table projects on my retina, and when I change the position it always changes, but still my brain fixes the table as a constant three-dimensional object. This is a very refined inference to the best explanation, which of course works totally unconsciously, so we are not aware of that. But someone could say, well, this is an interpretation, right? So in face of this difficulty, how can we then separate observation from theory-loaded interpretation? The answer to this question which I give is the following. With theory-loadedness I mean only dependence on acquired theory, not dependence on inborn theories. So when I say an observation concept should be a concept which can be learned theory independently, I mean independently from those theories, worldviews, cultural values which humans have acquired in their cultural evolution, which are different in different cultures, but not those quasi-theory, which are not really theory, but not dependent on those, so to speak, assumptions which are inborn, which are genetically determined by what is common, what the common structure of the brain of all humans, right? So this is the first answer. But this is still not enough. Still, we don't have an empirical criterion of knowing when a belief has been formed by an act of pure perception, when our perception includes, of course, all inborn structures of our normal vision, but it does not include certain acquired theories, values, or certain expectation of the person. We still don't have a criterion to distinguish a belief caused by a perception of that kind or by an interpretation. For instance, some people are reporting that they saw the ghost of their grandfather in the night, right, in the dark somewhere. They saw it. I mean, we wouldn't believe that was what they really saw. They saw maybe something, a shadow, and being in some kind of excited emotional state, they figured it somehow, interpreted it, it's a ghost of my grandfather, or whatever. Some people report they saw Mary the Virgin somewhere, right? Some people report they saw an UFO, really a flying rotating UFO, right? Like a frisbee rotation disk, huge one. That's all their fantasy, right? What they really saw was maybe a polar light. So how do you distinguish here, right? That is a problem. That is really a problem, because some people, I mean, there are more serious things. Some people say, I see that you are a bad character. Right. I see. But how do you know that this people is a bad character? It's morally bad. I see it. Don't you see it? I mean, that's a really dangerous way of speaking in that way, because they don't see it, and it's their responsibility now to explain what was going on in their interpretation. The person probably may be totally good person, right? And they made some interpretational mistake. But if they take their interpretation as a perception, they will never find out what their wrong assumptions were. So it is important to find an empirical criterion here of how we can distinguish between what the people perceived and what was their interpretation. Another case where this is really important is judge situations. The judge and the testimonies. What the testimonies report about the crime scene, but do they really report truthfully what they perceived, or do they report what they thought was the case, right? That is very important then for judges and lawyers and to find that out, what the person did really perceive. Okay, so what could be a good criterion here? So it's not enough to ask, did you perceive it? And if the person says yes, then it is an observation statement. That's certainly not enough, right? So what are the criteria here? Well, the usual criteria for observability, which you find in the literature, well, at least these two. The typical properties of observation concepts and observation statements is that they're really strongly intersubjective, and they're theory, culture, and value independence. I mean, but that is already the thesis also. I mean, that's debated. But these are really, if you look on the facts, these are very typical properties. Because look about different cultures, think about different cultures like fundamentalist people living in Islamic countries, even today, being very, very fundamentalistically religious. And people of our countries, very atheistic people, full enlightenment, right, era. So still, these people have no difficulty in agreeing about facts. The fundamentalistic cultures have no difficulty in accepting our knowledge in natural science. I mean, we wouldn't have any difficulty in agreeing that now it's raining or now it's not raining and things like that. I mean, even you know, totally persons with totally different political opinions, like extreme right and extreme left, I think they wouldn't really disagree about observation facts. That's the difference, right? They probably would already agree about certain theories. For instance, like religious people wouldn't believe Darwinian evolution theory, right? They don't want to believe that, even if it's supported by the fact, because it goes against the credo or the worldview. And even more, they won't agree about many norm and value statements. So, but there is agreement which usually goes unnoticed, right? It works always in all everyday language communication situations that we agree about the simple observation facts. So we all agree about that there's a screen here, there's a whiteboard here, etc. Right? So this is a salient property of observation statements, this intersubjectivity. So there was a question, yes?
Yes, what about people who hallucinations, because they are highly subjective, right?
Yeah, but as I said, we are agreeing almost always, right? This is what I said. So, and we are almost never hallucinating. This is what follows from what I said. We are almost never hallucinating. That is, some people are often, but my most quantifier was ranging over persons and times. So, of course, some very schizophrenic people are often hallucinating, but that's the reason for why they need an intensive psychological therapy then. Yeah. And of course, if you all are hungry, thirsty in the desert, and starving for thirst, then maybe most of us are starting to hallucinate, right? Or if you climb mountains without Ochigang mask or something in the, say, 8,000 meters high, then you start hallucinating. Lots of people do that. But then of course, it's different. Yeah. Now, yeah, but there's a more difficult problem, is the problem of language dependence. So observation concepts should, of course, they should be independent of the language community in which we are. And this is the most serious objection against the theory neutrality of observation concepts, because we know that different cultures have different systems of even of observation concepts. These were the findings of philosophers of language in 1930, 1940, 1950, right? And starting at that time, 1940s, 1950s, when they met primitive or native tribes, right, from non-developed countries like New Guineans or Polynesian islands or whatever, African tribes, Indian tribes, and for instance they found out that this was a finding of Worf, right, who is the inventor of the linguistic relativity principle, right? Linguistic relativity, as he calls it, that, for instance, the Sunni Indians, that was debated a lot, have no concept for orange. And what Worf concluded, and lots of people concluded from that, is that they cannot perceive the color orange, right? And this idea was communicated in the intellectual community for many decades, and still lots of people believe it today. There is this wonderful book of Berlin and Kay, which is then brought more light into this debate. They found out that, of course, there in Australia you find, for instance, cultures, the Dana, I think they are from Africa, Dana, yeah. You find native tribes who even possess only 3 primitive color words, right? I think white, dark, and blue or something, right? Only 3 words for colors. So, but what then they found out is these people can learn the colors for which they don't possess a word. So, but how can they learn it? I mean, do they learn it by learning the Western language? If that would be the case, the proponents of linguistic relativity would of course argue, well, but then they learned our theoretical framework, and in this way they started to see orange, which they didn't see before, right? But that is does not refute language relativity. But the point is that there is a way of non-verbal learning by means of an ostensive learning experiment. That's how I call it. In psychology it's called a non-verbal learning procedure. So what people did is just they tried whether these persons can learn, for instance, the color orange by non-verbal training. A non-verbal, an ostensive learning experiment, or non-verbal learning experiment, as I call it, ostensive, works as follows. You have a training set. This is a set of, say, 20 instances, say, of objects. Some of them are orange, some of them are not orange. So you have positive and negative instances, and you show this to the person who is the learner, the intended learner, and you tell them this is orange, and this is not orange. You need not have even the concept orange here, right? You can take any artificial word for it, like this is blah blah and this is not blah blah. And the question is whether this person is able to abstract the right property cluster from these learning instances and transfer it to new unknown cases. So in the test phase, you present this person then after the learning phase or training phase, you present them test instances, objects for which you didn't give information to the person, and ask, is this orange or is this blah blah? And if the person then is able to correctly answer the test question, then the person has learned the concept, right? And it turned out that for these simple color concepts, these persons of these tribes can easily learn them by means of an ostensive learning experiment. That means that they can perceive the color. They have no primitive word for it. Maybe because the color, probably because the color is not important in their environment, or whatever, on whatever reasons. Language evolution is a complicated story, you know, semantic language evolution. But they can perceive orange. It's even so that in some of these tribes, they don't possess a color word for red, right? But even in that case, they know how to refer to the color red by a circumscription. So they call it the color of blood, right? The color of blood, because, you know, obviously in this environment there are no other important red things than blood, right? So red is the color of blood. So they don't have a separate simple word for that. So on this brought me to the idea that you should and you really can characterize the observability of a property by the degree of its ostensive learnability by way of an ostensive learning experiment. So that is my account. My account is inspired by some writings of Quine, who also speaks of the ostensive meaning or the stimulus meaning of observation concepts and makes suggestions that go into that direction. But I distinguish from what distinguishes my suggestions from Quine is that Quine, so to speak, cannot carry this idea through because of his rejection of any separation between analytic and synthetic. I won't do that. So for Quine, for instance, as I had it, the empirical concept of water gets theory load, and as soon as you believe and strongly accept the chemical theory that water is H2O, then for Quine says, but then so everything, you know, what you know about the concept belongs to the meaning of the concept, right? So if an empirical concept, in my sense, if an observation concept, in my sense, is part of a theory, it's connected by way of these bridge principles, then the concept becomes theory loaded for Quine, not for me. Because I separate between the meaning of an observation concept is defined by that stimulus part, and its connection to a theoretical concept for me is a synthetic principle of the theory, right? That is my way of seeing it. So in case of colors, for instance, I would say that the color red as an observation concept is characterized in a certain perceptual way. And we should distinguish this concept of red from the physical concept of red as a certain wavelength, right? And in that case, the distinction is even more obvious, because the notion of a wavelength doesn't depend on normal conditions of light, while the concept of appearing as red depends on the wave spectrum of the light by which we see the color, right? So it seems that for me this is just a more plausible way to go. Therefore, different from Quine, I think you can go this way straight ahead, straight along. I mean, Quine had his problems, he somehow were ambiguous, but I really go this way and arrive at this position where I say, well, this is the best way of explicating what observability of a concept means. And according to this suggestion then, what you get is a gradual scale going from observation concepts, which you can really learn by a few training examples, over more complicated but still empirical concepts for which you need a lot of training examples, right? Very complex concepts, right? Like being red and circle and round, or green and quadratic, right? That would be a complex empirical concept which is not so easy to learn, and there are much more complex empirical concepts. At the end of the spectrum you find theoretical concepts like an atom or a magnetic field, which certainly cannot be learned by a member of a native tribe by way of pure extension. It would be simply impossible. How should member of a native tribe learn the concept of an atom by pointing to it, or the concept of a magnetic force. I mean, that's not possible. He would always confuse it, right, with other things. He really would have to learn, you know, the background theory. And for that purpose, he would have to learn part of our language. So there, Humboldt and Wolff are right for theoretical concepts, right? Okay, so this concludes my suggestion how we should set up the graded distinction here. Any questions so far? Yes?
I try to challenge this view, and
yes.
For example, if I try to explain to a child what 1 and 2 means, the numbers 1 and 2, I can show one object and say, okay, that's 1. That's another 1. Mm-hmm. And now I try to explain what 2 is. Mm-hmm. Like these 2 objects.
Okay.
That's 2.
Yeah.
That's not 2.
Yeah.
So I used extensive ostensive learnability to explain numbers, but I have the intuition that numbers are not observation concepts. But I can also use this technique to explain abstract concepts like numbers.
Yeah, yeah. So
there need to seem to be more criteria, like a visual appearance or something like that.
Yeah, I mean, first of all, with these learning curves which you get if you make experiments of that sort, right, you have clear observation concepts like that one, concepts which are learned, but you need really a lot of cases, and then concepts which are never learned, right? I mean, this is the thing. For what purpose is this important? I mean, there is nothing, no means by which you can solve all problems. This is important for the following thing. For having a position which establishes a kind of weak but still objective rationality criterion for theory progress. I mean, if you have 2 competing theories, right, what you need is to have at least some common non-theoretical language for which these 2 theories imply certain predictions, and so that the proponents of the 2 theories agree on them, and then they agree on the confirmation results for these experiments, right? Then they may agree really that is so to speak a barrier against radical incommensurability, right? For that purpose I need it. I also would say that the concepts, that is very important, very important. The concepts which are really ostensibly learnable in this narrow sense are very little. Only a small part of our concepts are observation concepts in this very narrow sense. And what you call in science empirically measurable concepts in the wider sense, these are concepts where I just assume certain unproblematic background theories, which are no longer in question, right? These are the observation concepts in the wider sense, which are of course much broader. So, but still, it's a way of that's how it works, right? Really in science. And I mean, you have of course situations in science where 2 theories agree on all consequences which they have for the joint accepted empirical sublanguage, and they differ only in regard to consequences which so far are not at all measurable. So it may be that by means of this small basis of theory-neutral observation concepts and observation sentence, you cannot discriminate, which cannot say which theory is better. But then they are evidentially equivalent, right? And as we know in philosophy of science, these situations happen. So you see, you don't expect too much from that criterion. Now, you even now ask a still more difficult question, namely, how does this criterion apply to mathematical concepts? Because numbers are not theoretical concepts in the sense of empirical theories like force and mass. Numbers are mathematical concepts, so this is just a new question. I didn't speak at all about that. But if you now want me to speak about that, it's just a different topic. So you cannot throw everything together. How do you learn mathematical concepts? Oh, well, you see, some philosophers of science would say, well, I learn it by it's a by logical abstraction. Some people would say I can learn it by empirical observation. We just had yesterday the talk of Gila Scheer, who was here. She said, well, you learn it you can learn it, right, by observation. What you know from psychology is, of course, you spoke about teaching children. I'm speaking about adults here. I speak about of normal conditions of observation. So of course, only children at a certain age can learn number concepts. But if they have that age, interestingly, they can learn it by observation, right? As you said it. So, in that sense, numbers are not theoretical concepts in the sense here, where we really need an explicit background theory. You're right. Yeah. So there's different, but still, number concepts are concepts which need a lot of logical abilities. So that just shows that logical mathematical concepts are just to be treated differently. Yeah, that would be the conclusion. They would somehow fit in between in this gradation scale, but that wouldn't say much about their nature because they have particular features. Anyhow, so what I end up is the following characterization. Concept B is a theory-neutral observation concept if almost all humans can acquire this concept in an ostensive learning experiment under normal conditions of observation, independently of the background condition, the background for information, language and culture. And normal observation conditions include, in the case of visual perception, not only the physical conditions, but all the psychological conditions. You must have a normally developed brain, visual brain. So you must, of course, be adult or something, right? I mean, speaking not about babies, right? That's, of course, different. And so on, right? So that is the idea. And I'm speaking about, not about logical or mathematical concepts here, but I'm speaking about concepts that refer to particular individuals or properties or relations in the world, right? So that is the idea. Okay. So if there are no further questions, or no? Yes.
I'm wondering whether still, even with ostensive learnability, there's some form of relativism, because certainly it might be that if you are in such a situation in a ostensive learning experiment and you are shown certain things, which hypothesis you formulate might depend on what you think is important about what you see.
Yeah.
If you don't think color is important, you might not even pay attention to the color of it.
Yes, but that is a very different thing. You are obviously right. I mean, if you try to make a crucial experiment, or at least an experiment which decides gradually between two theories, then what is important is that you have a common language, common consequences, a common language in which you have consequences, but the consequences should be different, of course, if you want to decide, and then both proponents agree that a certain result was the case, and it speaks as in case in favor of theory 2-1 or theory 2-2, or maybe in favor of both, but then it doesn't so to speak decide in a decreed way. Not decide, but then it doesn't change, so to speak, the balance of probability, right? It doesn't change the degrees of beliefs towards one as opposed to the other theory. So that is what we need. I mean, if the theory proponents don't agree that this experiment is important, we could, T1 says, we could do this experiment, that's not important for me, I don't want to do it. Now that's a different matter. But there are norms in science by which say that you should, if there comes some serious challenge, then you should always meet the challenge, right? You should do the experiment. These are just norms. That's why we have these general norms in science, that you should never, it's never a good attitude to put your head in the sand and say, I don't want to do this experiment. I don't want to look at this possibility, right? That's never a good attitude. Okay. Good. So now I turn to the next part. Empirical disposition concepts, as I said, they lie between these observation concepts and theoretical concepts. So I again start with Carnap here, because Carnap dealt with empirical disposition concepts and struggled with them in many writings, because you know, you have to start from the fact that in the area of behaviorism and operationalism was also very influential in 1950. Operationalism, and this was the idea that all theoretical concepts can be handled or treated like empirical disposition concepts. And the later Carnap recognized that this is not the case, right? But anyhow, to understand what is the nature of theoretical concepts, we first have to look on empirical disposition concepts. So as I said already, an empirical disposition cannot be ascertained or perceived by an act of pure perception under normal conditions. No, you have to do something with the object which has the disposition. So this is different, right? If I perceive that the object has a color red, I don't need to manipulate the object. I just have to have light. But if I want to find out whether something is soluble in water, water soluble, right? This is now the disposition concept. Then I have to give it into water and see whether it dissolves. So if I don't give the object into water, for instance, because I cannot give it into water, right? Then I cannot find out by empirical means whether it has the disposition or not. Therefore, Carnap suggested to explicate the meaning of a disposition concept by a sentence of this form. Though if a certain test condition is realized, then the presence of the disposition is equivalent with, occurs exactly if a certain test result, a certain result obtains. This is a form of what Carnap called a partial definition or a conditional definition of the condition of a certain test operation. So if X is given into water, then X is water soluble if and only if it dissolves. If it's not given into water, you don't know. Of course, in that case, if you have background knowledge, you could infer it from background knowledge whether it is soluble or not. But we don't assume this here, because then the question is, of course, where get the background knowledge from? I mean, here we are at the stage where we just consider fundamental empirical dispositions, right? Because, you know, ultimately the postulate of theoretical concepts and theoretical principles is later on justified, as you will see, by a certain structure of empirical dispositions, by a cluster of empirical dispositions. You will see that soon. So if you follow this chain of justifications, then it would not make, I mean, it's not, of course you could say we justify empirical dispositions by theories, but you know, in order to justify the theories, you need to have a concept of empirical disposition which also works without theories. And this is a concept. So it's a partial definition. Okay. Now, I could mention also some complications here. For instance, the complication that I omitted the time variable here. So in fact, the situation is a little bit more complicated. You have here a time variable, and here a time variable, and here you don't have a time variable. So you say if at some time an object is given into water, then it is water soluble if at that time or a little bit later it dissolves. If you formulate it in that way, you have a partial definition of what is called a permanent disposition, and that is so the assumption is here that if an object has a disposition, it has it permanently, or at least for all times of a certain time span. So there are differentiations here concerning time. But so if you have questions on that, I will answer them. But as long as you don't have questions, I don't go into details here, because that's not relevant for my story, or for my point here. What is important from my point is that a disposition is always an abbreviation of a temporal regularity, right? if I do something with an object, it reacts in a certain way, and this temporal regularity is possessed by certain objects and not by others. Right? And those objects who possess this temporal regularity are said to possess the disposition. And of course the disposition need not be eternally permanent, but it must be stable for a certain time in order to be detectable at all. So, now the really important point is the following. The meaning of the disposition concept of being soluble is fully explicated by this one law of correspondence. So this law of correspondence for soluble, for the disposition concept, is analytically true. But this was also the position of the late Carnap. So it fully explicates the meaning of, that is the meaning of being soluble in water, right? You know, not that I don't have a Quinian position for empirical concepts. I don't say that it gets theory loaded if water soluble is now, it's then somehow related to theoretical concepts. That is the meaning of water soluble, right? Okay. So let me now speak about the difference between a disposition concept and a theoretical concept. So in my view, and this is a so-called standard view about dispositions, and I think this is the right view, disposition concepts designate functional properties like solubility or elasticity. It's even a better example for some points which I want to make. While theoretical concepts designate categorical properties, speaking about, for instance, a molecular structure or a force. So contra Quine, contra Bird, Mumford or others, contra the operationalist, I argue that empirical dispositions are not equivalent, not identical, and should not be identified with unobservable structures. Theoretical concepts denote unobservable structures. Dispositions are those functional properties which are caused by the unobservable structures. So why do I go for that view? On two reasons, I think. This view is that view which is really supported by science. I mean, if you don't look on science purely philosophically, the other view may have some attractions, right? But it's not in accordance with what goes on in science. First point, elasticity. Elasticity is clearly a functional property. Quine wanted to identify dispositions with theoretical structures because Quine didn't like these partial definitions, and if you define, there's another way of doing it, define dispositions by counterfactual sentences or by law-like implications. He didn't like these intentional logics, so that was the reason for Quine. But elasticity is not I mean, you know, a metal is elastic and a rubber band is elastic. Both are clearly elastic, but the molecular structure are totally different. So the relation between the disposition and the structure causing it is certainly one to many. Now Mumford has an answer to that problem, but it's also, his suggestion doesn't work because the relation between dispositions and structures is not one to many, but it's really many to many, as you will see soon. So on the one hand, the same disposition can be caused by radically different structures. On the other hand, every structure causes many, many different dispositions. And this is the major point which I want to make here. If you look at this is the second point, why it is really impossible then to identify molecular properties, structures, like with dispositions. So let us look, and that was accepted, this insight, by Carnap in the very late stage of his work, like in 1966. Let's speak about, again, the disposition of being soluble in water. So what is the theoretical property that causes this disposition? It's a so-called dipolar structure of molecules, right? A substance which is soluble in water has molecules that are polarized, that have a negative charged end and a positive charged end. The reason why this substance is soluble in water is that water belongs to those liquids who also have a dipolar structure, whose molecules have a positive charged ends, actually two positive charged ends in that case, the two hydrogen atoms, and a negative charged end. And so these substance molecules insert themselves into the liquid molecules so that the negative end and the positive end go together, and that saves energy, that is very energetically has a positive balance, is favored, so and that is a state to which they want to go then, the molecules, and though they are all, they insert themselves totally into the molecules, and that is nothing but, that is exactly dissolution. That is a theoretical molecular reason for solubility. But obviously, having a dipolar structure is not identical with being soluble in water. I mean, that's just one, soluble in water is just one disposition following from that structure. Every substance which is soluble in water is soluble in all polar solvents. All solvents, all liquids whose molecules have polar structure, like ammonia, water, etc. Every substance which is soluble in water is non-soluble in all non-polar solvents, like in oil or benzene. So every substance which is soluble in water, I know the theory entails implies that it won't be soluble then in oil. There are several other dispositions which are caused by the same theoretical structure here. For instance, a substance which is soluble in water has a higher melting point because it's harder to melt a substance which is polarized molecules, because they have a stronger bonding energy between the molecules of the crystal. The solutions of this substance will conduct electricity in electrolysis, right? And so on. It will absorb and emit radiation of a certain wavelength. So all these empirical dispositions go together. So, and also, this is the situation. Though a theoretical property causes many empirical dispositions. That is the crucial difference between a theoretical property and a theoretical concept designating such a property and an empirical disposition concept. By the way, this is also for the context of justification quite important, because that is exactly one of the major reasons why scientists postulate theoretical structures which are not directly perceivable, right? Because they observe that certain substances have certain dispositions in common, right? If a substance belonging to the class, this class, has one of the dispositions, it has all of them. Why is that the case? It's certainly not the case that these dispositions are causing themselves, because these dispositions are functional properties. They are not causes in the ordinary sense of the word. It cannot go. So therefore, the reasoning is then there must be some common cause, right? So it's a kind of common cause abduction here, by which scientists infer to a certain structural features of the substances. Even if we cannot perceive them, they must be there, because that's the only explanation which is reasonable and fits with the background knowledge. So this is a difference between theoretical concept and empirical disposition concepts. Now, just to say this again, each empirical disposition concept provides a law of correspondence for the theoretical concept dipolar molecular structure, but they cannot all be analytically two together, right? The idea is, the question is, do these empirical dispositions and the correspondence laws for them characterize the meaning of dipolar structure in the usual sense, like for empirical disposition concepts? If they would have to be treated as being analytically true, as semantic principles. But that cannot be, because taken together they entail empirical predictions, like those which I already told you. If a substance has been dissolved in water, then it won't dissolve in oil. by the way, this kind of prediction is also a nice example of what I call a novel prediction. So this is a potential of theories to entail what one may call novel prediction, because it is what I call cross-sectoral. You know, with the background theory in the back, with the theory in the back, you really now can make predictions like, so it dissolves in water, the substance. It won't dissolve in oil, even if you gave the substance never into oil before. Right? By means of empirical induction, you couldn't do that, because induction always infers from what you did several times to an inference about what will happen in the future. But to make the prediction that this substance won't dissolve in oil or in any of these nonpolar liquids, just because I observed it didn't dissolve, it did dissolve in water, and from that I observed it has dipolar molecules, that is a typical theoretical inference. And so you see what is also an important feature of theory is that they entail some kind of novel predictions. Okay. But for us what is important here is, so we see the meaning, these correspondence laws, you know, each of these correspondence law for the disposition figures now, of course, as a correspondence law for the theoretical term dipolar structure, but these correspondence laws cannot be analytically true because they entail empirical predictions. And if that is the case, then the question is, what explains to us the meaning of the theoretical concept? How is the meaning of the theoretical concept explicated, if it's not explicated by these correspondence laws? Well, in the case of dipolar structure, the meaning of a dipolar structure is explicated by even more fundamental law, right? Dipolar structure means the molecule has two ends, one has a positive charge and another one has a negative charge. Though there's a more fundamental notion of charge here. And so the question of meaning explication, of the semantic characterization of a specific theoretical concept is just transferred to the question of the semantic explication of a more fundamental theoretical concept. This is the case here in this case, right? But then the question arises, how is the meaning explicated in the case of fundamental theoretical concepts, right? This is the real question then. But and to which I turn now. But before that, so I come now to the next slide, where we ask, how is the meaning of fundamental theoretical concepts then explicated? But before I turn to that, are there any questions so far? Yes?
Are there any people who maybe question how many of our empirical concepts are empirical disposition concepts? So for example, you were mentioning before some test condition has to be satisfied, but somebody may say, well, color, we can understand color as a dispositional concept. Why? Because the test condition of light has to be present. So test condition doesn't just have to be something initiated by a human being, it can be something naturally initiated.
Yes. Thank you for this point, because that's exactly how I then distinguish to separate observation concept from empirical disposition concepts, by saying that observation concepts are those empirical disposition concepts where the test conditions are normally satisfied under normal conditions of human evolution, those conditions under which the perception organs evolved. But they don't have to be satisfied by means of human intervention. And that's a whole difference here, right? So the normal conditions are the test conditions, but they are normally the case. While for proper disposition concepts, the test conditions have to be realized by human action. And that is a typical activity of scientists and of science, that they really experiment with the objects of their environments. They start to experiment. As long as people don't do experiments, right, they don't find out, the knowledge doesn't expand, cannot really rapidly expand. Only if they start to manipulate the objects, put them under very many different conditions, which many of them they wouldn't observe under normal conditions of observation, and it works, right? When people invented agriculture, well, they started to manipulate the little wolves, which always came when they had a nice food, a nice meal, and they started them as co-workers in their hunting strategies. They used them for hunting, and that was an invention, right? And so on. So this is a difference between, in my view, between empirical disposition properties. The test condition has to be realized by human intervention. Is not normally the case. Observation concepts, the test condition is here the normal condition. Okay. If there are no other questions, then I go on. So now I go on and come to the question, so if you agree now with me that theoretical concepts are not simple empirical disposition concepts, but they designate unobservable structural properties which cause many dispositions. How do we then explicate the meaning of fundamental theoretical concepts for fundamental ones like charge or like mass? I will discuss this problem now at the end of the fundamental concept mass. And my answer is, well, you explicate the meaning of mass by means of several laws, more or less fundamental laws of correspondence for mass, and that's it. That is the explication of meaning. Now let's see how we usually would explicate and how physicists would explicate the meaning of mass. Well, in our life, on our everyday life, on our planet Earth, right, we have two major methods of determining the mass of objects, of ordinary sized objects. Both are concerned with one disposition of mass, a fundamental kind of disposition, so to speak, which has specific versions of it. But the fundamental kind of disposition is the disposition of weight to be attracted by a gravitational force, though this is also called the heavy mass in physics. So for instance, by a spring scale you can measure the mass by way of this partial definition here. If the object is placed on a spring scale, then the mass of X is k units exactly if the spring is stretched or it is compressed, depending on the kind of spring, right? By k units of length. Right? This is the spring scale measurement of mass. Right? If you cannot place the object on a spring scale, then you don't know. I mean, then you can apply this measurement law. So you see also here that laws of correspondence really figure as measurement laws, right? As empirical identification laws. If an object is too heavy, I mean, you cannot weigh the mass of the Earth by means of that, for instance. You cannot put the Earth on a spring scale. Another way of measuring is the beam balance. Law of correspondence says that if the object is placed on the beam, then the mass of the object is k unit exactly if the beam on the beam is balanced out by k units of mass which you put on the other side of the beam. So both laws of correspondence and both dispositions are dispositions of the weight, though dispositions of heavy mass, right? The result of the disposition of mass to be attracted by a gravitational field. In the second case, with the beam balance, you apply the physical law of acture equals reacture for the balance, for the implication following from the balance point, where it follows then that the mass on the right side must be equal to the mass of the left side, right? Okay. Also, both dispositions are dispositions of the mass in gravitational fields. There's a difference between them. Can someone tell me the difference or see it? So think about how what result these measurements would give on the Earth as compared to the Moon. Who can tell me that? Maybe?
It depends on the strength of the gravitational force, which would be less on the Moon.
So what? So
on the Moon it would.
Which one?
On on the spring scale, for example?
Yeah, the spring scale would depend on the gravitational strength of the moon, of the field. So if I measure the weight of the force, if I measure mass on the moon with the same spring scale, then my mass would come out not to be something like 85 kilo, but just 5 kilo or so, because the gravitational strength of the gravitational field on the moon is much less. But what with the beam balance?
Well, in this case, the gravitation would be less for both sides.
So it wouldn't matter, right? So it wouldn't matter. So that's a very different thing. So the beam balance works in all gravitational fields which are homogeneous. So all what is required for the beam balance, for applying the mechanism of the beam balance, is that you have a field whose gravitational field lines are parallel within the size of the beam balance, right? So that there's really the same force in both directions, and by applying the law of torque, right, you get that the beam is balanced exactly if these two forces are equal. So if you have unit masses on that side, exactly when they balance, the masses here and here will be the same. So it works independently of the strength of the gravitational field, while the first disposition works independent of the strength of the gravitational field. So that's already, you see why you need these different, why you have these different dispositions. So the dispositions have to do with heavy mass, but they're different. Still, there are dispositions of the same kind. But now the question comes, how do I measure mass in the state of weightlessness in a space shuttle that is orbiting around the Earth, right? I mean, it should be important for the space shuttle pilots to keep their diet and to weigh their mass. I mean, how do they do that? Certainly not with the spring scale or the beam balance. Anyone has an idea? Yes?
I don't know the term, but they could do circular force.
Okay. Yeah.
By that measure.
Well, yes, exactly. So there's a second fundamental kind of disposition which mass has, and this is the inertial mass, as it calls in physics. That works without any gravitational field in an outer space, and it has to do with the laws of momentum, but more fundamentally it is based on the Newtonian force law. I mean, we're speaking about Newtonian physics here, that for every change of the velocity of a body, of particle, you need a force, right? So there are two kinds of changes of velocities. You may change the amount of velocity in the case of a straight movement in one direction, straight direction. These would then be the laws of momentum. So, so if a particle moves and collides with a second particle, right, and if they hang together after the collision, that's called an inelastic collision, then after the particle they have the residual velocity v star, and this says 1 kilogram. Then that would be one way of measuring the mass. The outcome is that the mass then is v minus v star divided through I think what is it? I think that is the outcome, right? Something like that. No. I have it in my book. My book is more intelligent than me. Yeah, exactly. Just the other way around. The measurement outcome is V star divided to V minus V star. So that's one way of measuring. You could do that in a space shuttle by moving towards 1 kilogram, catching it while you're moving, and then measuring your reduced velocity before and after you catch the 1 kilogram. But that's a not nice way of measurement. The better way of measurement, as you actually do it in the space shuttle, is by rotation, rotation apparatus. So in that case, you change, when you rotate, right, you change the direction of velocity. That needs also a force. This is called the centrifugal force, which causes a certain spring here to stretch, and so you are in rotation chamber, And if you have a certain rotation speed, you can measure the stretch of the spring which holds you, and by that you measure your weight. And that doesn't need so much space than the other experiment. So that are the two fundamental ways by which you can measure the mass even in a state of weightlessness. This is called the inertial mass in physics. Now, interestingly, there is even a debate among physicists, but this debate is largely influenced by the operationalist view, which says that you should identify all theoretical concepts with empirical dispositions. Now, that doesn't work really in very detail, but at least you should identify theoretical concepts, as people say, with a fundamental kind of disposition. And so physicists started to discuss whether these are not really two different kinds of masses, heavy mass and inertial mass, right? Whether this is really one concept, because they are really two fundamentally different kinds of dispositions. But if if you have the viewpoint which I have and think it's the right one, that theoretical concepts cause dispositions but they are not identified with them, this debate is I don't say that it has no point, but this debate has not such a principal point, because of course that the mass causes two fundamentally different dispositions is no reason that you don't have one theoretical property here. The theoretical property is one, and it's the common cause of two different dispositions. Of course, still there's always the question, whether a set of correlated dispositions is really caused by one cause. I said before that by common cause abduction, if you have a set of correlated empirical dispositions of a certain kind of object, then you want to explain this by a common theoretical property, a common cause. But it is not clear, especially if these positions are not strictly correlated, whether you really need only one cause or several causes, right? We'll return to that point later. But in that case, it is obvious that one cause is enough, because these dispositions are really strictly correlated. There is no way by which in physics by which a body could have, no physical theory allowing for the possibility that a particle could have an inertial mass without having a heavy mass, right? If that would be the case, then it would be different. But as long as this is not the case, there's really no reason not to speak of one common cause of these two different dispositions here. Okay. Now, I also mentioned that there are, of course, several other and more specific laws of correspondence. For instance, laws of correspondence for very small particles, for particles of molecular size, which you cannot put on a balance beam, on a beam balance, and you cannot put them on a spring scale. Like you have to design a specific experiment to measure their mass. For instance, you may design a sinking velocity experiment where the small particles sink in a liquid and you measure their sinking velocity, right? Or how do you measure the weight of the Earth? What would you say? I mean, or the weight of the Sun? How do physicists measure the weight of the Sun? Anyone has a clue? I mean, yeah, no?
Maybe by the frequency of the rotation of the planets.
Yeah. I mean, that's one way. If you know the weight of the Earth, right, on the other planets, especially of the Earth, it would be enough to estimate it. Then you can, by using the Newtonian theory, you can infer the weight of the Sun approximately. But how do we measure the weight of the Earth, right? That is difficult enough. You somehow have to measure, the volume of the Earth. But you have to somehow grab an idea of the density of the Earth in its inner part, right? And the density of the Earth in its surface in the layer of 10 kilometers maybe, but not then the magma is very heavy, and so on. So there are lots of very specific measurement methods for mass, but these, which I told you here, are just the fundamental ones. The fundamental measurement methods for mass, two fundamental ones, spring scale and balance beam, for the beam balance, so that's how we say it. Spring scale and beam balance for the heavy mass, inelastic collision and rotation, centrifugal force for inertial mass. Okay, good. So now, I said, let us return, I said, these are the fundamental laws of correspondence for mass that explicate the meaning of mass. It's a fundamental concept, so we have no other theory which could help us here. Those laws of correspondence explicate the meaning of mass. So can they be understood as definitions of mass? No, they can't. Why? Because, again, the same thing. Taken together, already two of these laws of correspondence have empirical content. So they're contentful. They cannot be analytically true, though they can't be proper definitions. They are part of the theory, they're empirically contentful, so they're refutable, they're correctable, etc. They have empirical, they can be empirically confirmed, right? Now the content is just gotten by putting those together. If T1 and R1 and T2, then R2, meaning that if an object has been put under test condition 1 of disposition 1 and reaction 1 obtained, therefore it has the property of mass so and so. And then if you put it under test condition 2, then it will exhibit reaction 2, measuring mass in another way. Right? For instance, for mass, if you have put body on a spring scale and it turned out to compress the spring by 10 mass units, and then if you put it on a beam balance, then it will be balanced out by exactly 10 mass units on the beam balance. That is an empirical prediction. That is important here. And if you put that same body in a space shuttle in a weightless state in the outer sphere, and then they measure its mass in a rotation chamber, then you will have 10 a corresponding result. So this is a crucial point. But what follows from it? Well, it follows that laws of correspondence are not analytically true postulates. Rather, they are synthetic in nature. They possess empirical content. Now this little logically almost trivial result is philosophically totally important, and Carnap struggled with this a lot. Because originally, of course, the idea was that these partial definitions, these laws of correspondence, somehow characterize the semantic meaning of these theoretical concepts. But now we see this cannot be done. I mean, what at most could be done is that you single out one of the many laws of correspondence and say, this single law of correspondence, that is a definition, the partial definition of mass, and all of the other ones are synthetic assumptions or hypotheses. But that would be somehow completely arbitrary. Why should you just single out that and not another one? I mean, that would be a weird kind of immunization strategy for one of them. I mean, there's no reason to do that. So what you end up then is, and that was the consequence which philosophers of science in the 70s draw, in the 60s draw, 60s, 70s, we discussed a lot of that, even of course today still. But it seems to follow the meaning of a theoretical concept is not given by a single definition, but it's rather determined by the background, the entire. First, I forget what I say here in the core of but the entire background theory to which this concept belongs. So mass, the meaning of mass is determined by the theory of physics, more precisely by the theory of mechanics. Right? The mechanics, we don't need electrodynamics now, or electrostatics. For mass, we need just mechanics. Yeah. And so this is a strong consequence. I call it also the error of operationalism. I put it in quotation mark because of course it's controversial, but I mean, as I said, the operationalists wouldn't agree to that, but there are no longer many operationalists out there, so it's somehow unavoidable that on all of this reason which I told you, that you end up with the consequence that operationalism is wrong. The meaning of a theoretical concept is given by at least all these laws of correspondence, right? Yeah. It's given by at least a part of the background theory. Good. So what are the consequences of this view? I mean, well, of course, you could jump from that to radical meaning holism. Joining this with the theory that observation concepts are always theory dependent, and everything, the meaning of a concept depends on all the background knowledge in which this concept figures or occurs. And that, of course, leads to a position which leads to really weird consequences, like the consequences like whenever two people disagree about the truth value of a statement or a belief, then they have different concepts, right? Because the meaning of their concepts depend on everything, on all of their beliefs, so they never can agree about the meaning of concepts. So I'm far away from drawing these consequences. I already told you that the empirical consequences, right, they do not depend on the theoretical concepts. I separate their meaning, and that is important for making empirical test operations and for singling out a common, so to speak, empirical charge or empirical sublanguage which is common to rivalizing theories. So this is one thing. You don't jump to radical holism by accepting, if you accept that the meaning of a theoretical concept is determined by the background theory. That doesn't lead to the total holism, but it does lead you to a holism in regard to theoretical concepts. That is important. Right? But this may be bad enough, or this may be drastic enough, because it implies that the following consequence. Whenever the theory changes, the meaning of the theoretical concepts of the theory has changed too. So think now about Newtonian mechanics and relativistic mechanics, general relativity theory, right? So, of course, certain core principles in these two mechanical theories changed, right? In particular, in relativity theory, the mass of a body becomes dependent on its velocity, right? In classical mechanics, mass is a permanent property, an intrinsic property of an object, independent of its velocity. So, should we not say these two theories speak about different things when they speak about mass? Does it follow that these theories are incommensurable in the Kuhnian sense, because they speak about different masses? I mean, that things were then debated in philosophy of science heavily. As I said, even if it were so, that mass is not commensurable, that there are really radically different notions of mass here, since I have this notion of an empirical sublanguage which is common to Newtonian mechanics and relativistic mechanics, which in that case would be the kinematical language which only speaks about velocities, particles, times, positions, and so on, accelerations, but not about masses. It's not so drastic, because still we could compare relativistic mechanics and classical mechanics in terms of this kinematic, non-theoretical sublanguage, right? But even that is too drastic. Why? Because if you look, then you really can see that there's a common core of mass which is common to both relativistic mechanics and Newtonian mechanics, right? Namely, all these correspondence principles for mass which hold in Newtonian mechanics hold also in relativistic mechanics under the condition that the body whose mass is measured and the measuring system are in the same inertial system. So to speak, the body whose mass is measured is at rest in relation to the measuring apparatus, right? If this is given, under this condition, so to speak, these semantic principles or these principles characterizing mass are true in both theories. So there's a common semantic core of mass, which is common to Newtonian mechanics and relativistic mechanics. So the meaning, holism of theoretical concepts, even at the theoretical concept level, is not as radical as it appears in some writings, say of Kuhn or so on. But it is there, but to that degree which I want to make precise. And on this reason, what you really should say is that the meaning of a theoretical concept is not given by a single definition, but is determined by the core of the background theory to which this concept belongs. So it is not really determined by all peripheral parts of the background theory, right? I mean, if I add a certain auxiliary assumption about a certain planet, that doesn't change my concept of mass, right? Or if I add a certain auxiliary assumption about whatever. But it is determined by certain core principles of the background theory, namely these laws of correspondence, which I told you, and which are the same in relativistic mechanics when the mass is at rest, but which change, which are no longer generally true if the mass that it measured moves, right? Okay. So any questions to this part of the talk? Additions, comments. So, concerning meaning, no. Good. So I recapitulate. The meaning of a theoretical concept is not given, like for observation concept, by an ostensive characterization. This is whatever. This is a gravitational field. It's not given by an empirical definition, but it's given by the background theory to which this concept belongs. Not by all parts of the background theory, but by the core principle of that background theory. Okay. So the next question then is, I've illustrated to you the relation between empirical dispositions, right? So temporal regularities on the one hand, and theoretical properties which cause these dispositions on the other hand. Two examples so far. At the example of solubility, so examples from chemistry, and the example of mass from physics. What is the situations in humanities and social science? So in humanities and social science you also find theoretical concepts, and you also find dispositions that are caused by them. So here the situation is really very similar. Usually in humanities and social science you don't speak of a law of correspondence, you rather call it an indicator. So you have here theoretical concepts on the one hand, and you call them indicator laws, and indicators on the other hand. So my first example is in psychology the concept of intelligence, or the level of intelligence, right? So this is a typical theoretical concept because people think that it is not identified really with the outcome of a particular test. There are really different kinds of intelligence tests. Each test is one indicator, and each test corresponds and each test result. So my performance on a particular test corresponds exactly to one empirical disposition which I have, right? But my performance on a particular test is not identical with my intelligence, because intelligence is a complex feature and has several dimensions and can be measured by different tests. So this shows that also here we have this distinction between theoretical concepts on the one hand that are the cause of several dispositions. A difference between physical sciences on the one side and humanities and social sciences on the other hand is that these indicator laws or laws of correspondence are entailed to a much lesser degree by the theory than in physics. So they are not really. So there is not really a psychological theory which entails that this and this and this and these are the right on all correct tests for intelligence. So the theories in social science are much less exact about the question: what are the right indicators of the theoretical concepts which this theory postulate. And this is a point where I will continue this topic in the next lecture. Thank you for the day.